The National Electrical Code does not have a specific maximum distance requirement for a light switch from a door within a dwelling. However, a generally accepted guideline suggests positioning the switch no more than 3 feet, which is approximately 0.9 meters, from the doorknob or latch. This recommendation is based on ensuring ease of access and convenience for occupants when entering or exiting a room. As for strapping metal-clad cable, the National Electrical Code permits the use of a one-hole strap as a mechanical connection point to a wall for securing the metal-clad cable. However, adherence to specific requirements is crucial. Firstly, the one-hole strap must be firmly attached to the wall utilizing screws or nails that are appropriate for the wall material and capable of supporting the weight of the cable. Secondly, the installation of the metal-clad cable itself must conform to the manufacturer's instructions. This includes considerations for bending radii, proper termination techniques, and any specific requirements outlined by the manufacturer for the particular type of metal-clad cable being used. Thirdly, if a black tie wrap or steel tie wire is used in conjunction with the one-hole strap to secure the metal-clad cable, it must be specifically rated for use with metal-clad cable. This rating ensures that the tie wrap or wire is capable of withstanding the environmental conditions, temperature fluctuations, and potential mechanical stresses associated with the installation. The tie wrap or wire must be properly secured to the one-hole strap in a manner that prevents slippage or movement of the cable. Fourthly, the metal-clad cable bundle must be supported and secured at intervals not exceeding 4 feet, which is approximately 1.2 meters, along its entire length. This requirement prevents the cable from sagging or becoming damaged due to its own weight or external forces. Additionally, it's important to verify that the one-hole strap is not overloaded. Overloading can occur when multiple cables are excessively bundled together, exceeding the strap's capacity to securely hold them. Furthermore, care should be taken to avoid over-tightening the tie wrap or steel tie wire, as this can potentially damage the metal-clad cable's outer jacket or conductors inside. Best practices include using appropriately sized straps and fasteners, ensuring proper spacing between supports, and avoiding excessive force when securing the cable. Consulting with a qualified electrician is recommended, especially when dealing with complex wiring scenarios or unfamiliar electrical systems. This ensures that the installation meets all applicable code requirements and safety standards. When installing electrical wiring, safety should be the foremost concern. Always disconnect power to the circuit before working on any electrical components. Utilize appropriate personal protective equipment, such as gloves and eye protection, to minimize the risk of electrical shock or injury. Familiarize yourself with the National Electrical Code guidelines and local electrical codes to ensure compliance with all applicable regulations. If you are unsure about any aspect of the installation, seek guidance from a qualified electrician. Adhering to these safety precautions will help ensure a safe and reliable electrical system. Electrical codes and regulations are in place to protect people and property from hazards associated with the electrical systems. These codes address a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The National Electrical Code, published by the National Fire Protection Association, is the most widely adopted electrical code in the United States. However, local jurisdictions may have their own amendments or additions to the code. It is essential to consult with local authorities to determine the specific electrical codes that apply to your area. Failure to comply with electrical codes can result in fines, penalties, and potentially dangerous electrical conditions. Always obtain necessary permits and inspections before commencing any electrical work. This ensures that the installation is performed safely and in accordance with applicable regulations. The National Electrical Code undergoes revisions every 3 years to keep pace with technological advancements and address emerging safety concerns. Staying informed about the latest code changes is crucial for electrical contractors, engineers, and anyone involved in electrical work. Resources such as the National Fire Protection Association website and electrical trade publications can provide valuable information on code updates and best practices. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. The National Electrical Code specifies requirements for grounding electrodes, grounding conductors, and bonding of metal enclosures. Ensure that all electrical equipment and systems are properly grounded in accordance with code requirements. Ground fault circuit interrupters are life-saving devices that protect against electrical shock. Ground fault circuit interrupters detect small imbalances in current flow and quickly de-energize the circuit, preventing injury or death. Ground fault circuit interrupters are required in areas where electrical equipment may come into contact with water, such as bathrooms, kitchens, and outdoor locations. Regularly test ground fault circuit interrupters to ensure that they are functioning properly. Overcurrent protection devices, such as circuit breakers and fuses, protect electrical circuits from damage caused by excessive current flow. Overcurrent protection devices are designed to trip or blow when the current exceeds the rated capacity of the circuit, preventing overheating and potential fire hazards. Select overcurrent protection devices that are properly sized for the circuit and equipment they are protecting. Never replace a circuit breaker or fuse with one of a high rating, as this could overload the circuit and create a fire hazard. Wiring methods are the various ways in which electrical conductors are installed and protected. The National Electrical Code specifies requirements for different wiring methods, such as non-metallic sheet cable, armored cable, and conduit. The appropriate wiring method depends on the application, environment, and voltage level. Install wiring in accordance with code requirements and manufacturer's instructions. Electrical boxes are used to enclose and protect electrical connections and devices. Electrical boxes must be properly sized and installed to provide adequate space for wiring and devices. The National Electrical Code specifies requirements for the number of conductors allowed in an electrical box, as well as the type of box required for different applications. Use appropriate electrical boxes for the intended purpose and ensure that all connections are properly made and secured. Electrical splices and terminations must be properly made and insulated to prevent electrical shock and short circuits. Use approved connectors and splicing methods to ensure reliable and safe connections. Wrap all splices and terminations with electrical tape to provide insulation and protection. Never leave bare wires exposed, as this could create a serious electrical hazard. Electrical panels are the central distribution points for electrical power in a building. Electrical panels contain circuit breakers or fuses that protect individual circuits. Electrical panels must be properly sized and installed to accommodate the electrical load of the building. The National Electrical Code specifies requirements for the location, installation, and wiring of electrical panels. Ensure that electrical panels are properly labeled and accessible for maintenance and repair. Electrical equipment, such as appliances, lighting fixtures, and motors, must be properly installed and maintained to ensure safe and reliable operation. Follow manufacturer's instructions for installation and operation. Regularly inspect electrical equipment for signs of damage or wear and tear. Replace damaged or worn-out equipment promptly to prevent electrical hazards. Working with electricity can be dangerous, and it is important to take necessary precautions to protect yourself and others. Always disconnect power to the circuit before working on any electrical components. Utilize appropriate personal protective equipment, such as gloves and eye protection. Never work on electrical equipment while standing in water or on a wet surface. If you are unsure about any aspect of electrical work, seek guidance from a qualified electrician. By following these safety precautions, you can minimize the risk of electrical shock and injury. In the state of Florida, adherence to the National Electrical Code is paramount for all electrical installations. It is crucial to consult with local authorities and obtain necessary permits before commencing any electrical work. Florida Building Code adopts the National Electrical Code with some state-specific amendments. These amendments may address unique environmental factors or specific construction practices prevalent in Florida. For example, Florida's humid climate and susceptibility to hurricanes may necessitate stricter requirements for weatherproofing electrical enclosures and securing wiring systems. Before undertaking any electrical project in Florida, it is essential to consult with the local building department or a qualified electrical inspector to determine the applicable codes and regulations. This ensures that the installation meets all necessary safety standards and complies with local ordinances. Florida has specific regulations regarding the use of aluminum wiring. Aluminum wiring was commonly used in residential construction in the 1960s and 1970s, but it has been found to be more prone to corrosion and loosening than copper wiring. As a result, Florida requires that aluminum wiring be properly terminated and maintained to prevent electrical hazards. If you have aluminum wiring in your home, it is important to have it inspected by a qualified electrician to ensure that it is safe and code compliant. In addition to the National Electrical Code and Florida Building Code, there may be other local regulations that apply to electrical installations in Florida. For example, some municipalities may have specific requirements for the location of electrical panels or the installation of surge protection devices. It is important to research and comply with all applicable local regulations to avoid fines or penalties. When hiring an electrician in Florida, it is essential to verify that they are licensed and insured. A licensed electrician has met the necessary qualifications and passed an examination to demonstrate their knowledge of electrical codes and safety practices. Insurance protects you from liability in case of accidents or damages that may occur during the electrical work. You can verify an electrician's license through the Florida Department of Business and Professional Regulation. Obtaining necessary permits and inspections is crucial for ensuring that electrical work is performed safely and in compliance with code requirements. Permits are typically required for new electrical installations, renovations, and repairs. The permit process involves submitting plans and specifications to the local building department for review. Once the permit is approved, an electrical inspector will inspect the work to ensure that it meets code requirements. Failing to obtain necessary permits can result in fines, delays, and potentially dangerous electrical conditions. Regular electrical inspections are recommended to identify and address potential safety hazards. A qualified electrical inspector can assess the condition of your electrical system and identify any code violations or potential problems. Regular inspections can help prevent electrical fires, shocks, and other hazards. It is especially important to have your electrical system inspected if you live in an older home or if you have experienced any electrical problems in the past. Electrical safety is a shared responsibility. As a homeowner, it is important to be aware of potential electrical hazards and take steps to prevent accidents. Never overload electrical outlets or extension cords. Keep electrical appliances away from water. Regularly inspect cords and plugs for damage. Install smoke detectors and carbon monoxide detectors to provide early warning of fire or carbon monoxide leaks. If you have any questions or concerns about electrical safety, consult with a qualified electrician. The National Electrical Code provides comprehensive guidelines for safe electrical installations, including specific requirements for metal-clad cable. Metal-clad cable, often referred to as MC cable, is a type of electrical cable consisting of insulated conductors enclosed in a metallic sheath. The metallic sheath provides mechanical protection to the conductors and serves as a grounding path. The National Electrical Code outlines specific requirements for the installation, support, and grounding of metal-clad cable. These requirements are designed to ensure the safe and reliable operation of electrical systems. When installing metal-clad cable, it is essential to follow the manufacturer's instructions and adhere to the National Electrical Code guidelines. Proper installation techniques are crucial for preventing damage to the cable and ensuring its long-term performance. The National Electrical Code specifies requirements for the support of metal-clad cable. The cable must be supported at intervals not exceeding 6 feet, which is approximately 1.8 meters. Supports must be designed to securely hold the cable without damaging it. Approved methods of support include cable ties, straps, and clamps. The metallic sheath of metal-clad cable must be properly grounded to provide a low-impedance path for fault current. Grounding ensures that in the event of a fault, the circuit breaker or fuse will trip, preventing electrical shock. The National Electrical Code specifies requirements for grounding metal-clad cable, including the use of approved grounding connectors and the proper bonding of the metallic sheath to ground. Metal-clad cable is available in various sizes and types to suit different applications. The size of the cable is determined by the ampacity, which is the maximum current carrying capacity of the conductors. The type of cable is determined by the insulation material, the type of metallic sheath, and any special features such as moisture resistance or fire resistance. Selecting the appropriate size and type of metal-clad cable is crucial for ensuring the safe and reliable operation of electrical systems. When working with metal-clad cable, it is important to use the proper tools and equipment. Metal-clad cable requires special cutting tools to avoid damaging the conductors. Approved connectors and fittings must be used to ensure secure and reliable connections. Always follow the manufacturer's instructions when working with metal-clad cable. Metal-clad cable is commonly used in a variety of electrical applications, including residential wiring, commercial wiring, and industrial wiring. It is a versatile and durable wiring method that provides excellent protection against mechanical damage and environmental factors. Metal-clad cable is often used in exposed locations where other wiring methods would be vulnerable to damage. The National Electrical Code recognizes metal-clad cable as an approved wiring method for a wide range of applications. However, it is important to be aware of any local regulations or restrictions that may apply to the use of metal-clad cable in your area. Regular inspection and maintenance of metal-clad cable is essential for ensuring its long-term performance and safety. Inspect the cable for any signs of damage, such as cuts, abrasions, or corrosion. Replace damaged cable promptly to prevent electrical hazards. Tighten all connections and fittings to ensure that they are secure. Keep metal-clad cable clean and free of debris. By following these maintenance practices, you can extend the life of your metal-clad cable and ensure the safety of your electrical system. Metal-clad cable is a valuable wiring method that provides excellent protection and reliability. By understanding the National Electrical Code requirements for metal-clad cable and following proper installation and maintenance practices, you can ensure the safe and efficient operation of your electrical systems. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns.